Pop quiz. If you were able to look back on the present from deep in the future, what age would you say we're living in?
Is this a trick question? I mean, I want to say information age, but it seems too obvious. Can I say more than one age?
Yeah, I think it is safe to say that we are living in more than one age. From the beginning of humanity, we've seen prevailing technologies marked with milestones. The Stone Age, the Bronze Age, the Iron Age, all occurring many thousands of years ago. Man's mastery of these materials has defined us. But by that metric, the last couple of hundred years have seen a flurry of ages. The steam age, the industrial age, the atomic age, the television age, the space age, to name but a few. But those are not the answers I was looking for.
Is that a clue?
Yes, it is. I think that this age could be classified as the Glass Age.
That's not what I was thinking.
I know.
So how are we in the Glass Age?
Well, let me put it to you this way. Can you imagine a world without glass? Now, I don't want a cheeky answer. I want you to really think about it.
Okay, no. I can't imagine the world without glass.
Exactly. Glass is really quite extraordinary. Without it, many of our major accomplishments would never have happened. Glass has a deep and complex history, and as a material, it has properties and characteristics that we are only just beginning to understand. We look right through it and think of it one-dimensionally. Most of us think of glass as a fragile, brittle thing that, if not handled correctly, will break in a spectacular fashion.
So you're going to break that to make a point?
Indeed.
Can I help?
Yes, you can. And it's true, our everyday common variety of glass is brittle, but it doesn't have to be that way. Glass has already altered our lives and is behaving in ways that is totally unexpected.
Got it.
Let's start with a history of glass.
I think I can handle that. Glass as we know it is most commonly made of silica, the primary ingredient of beach sand. Mix silica with a couple of other key ingredients, heat it all up till it melts, and bang, you got glass. Humans have been making glass since ancient times, starting with beads, vessels, and ceremonial accoutrements. Glass-making techniques spread out from Mesopotamia, culture to culture, changing in incremental ways for much of the last 4,500 years or so. The Romans even had glass windows on their important buildings as early as the 1st century AD. Glassblowing was discovered around that time, and soon inexpensive and ubiquitous glass became one of the hallmarks of the Roman Empire. But no period has seen such growth in the development of glass technologies as in the last 150 years. We've been able to unlock the secrets of glass in ways that would have seemed like magic to our forebears.
Nice.
Thanks.
So tell me what's so special about the last 150 years?
Well, several things. In that period, technology evolved at an exponential rate. With that came tools and processes that enabled advancement across all material sciences. The leader in glass material science was, and still is, an upstate New York glass company that started out in the mid-1800s, Corning Incorporated. One of their first products was a toughened glass lens for railroad signal lanterns that offered 2 radical improvements over any other lens of that time. It could be produced in a consistent color, and more importantly, it didn't break when rain hit the hot glass. This helped save lives by bringing down the number of train wrecks, but it also set a course for 160 years of innovation in glass. Of course, everybody knows about Corningware and Pyrex products too. Those innovations came from Corning during the early part of the last century.
You know, I have tons of this in my kitchen.
But Corning no longer makes kitchenware. They've innovated way beyond that. Let's take a look. We'll start with this.
Ah, optical fiber.
Right, optical fiber. This does 2 things, both astonishing. The first one is this.
That right there is pure glass. A glass strand inside the cable, tightly wound around a pencil and yet not breaking. When you stop and think about it, that is a mind bender. Okay, what's the second thing?
Well, it's the way the light moves through the glass. When the glass is bent this way, you'd expect light to leak out and get weaker and corrupt the data that it carries. But that's not happening. Nearly all the light entering this optical fiber is coming out the other end.
So it has a low attenuation?
Yeah, exactly. Very low. And the late 1960s, Corning figured out how to limit the attenuation or loss of light as it travels through fiber, even when that fiber is bent.
Nice.
This discovery led to the practical use of fiber as a medium for voice and data communications over great distances, ushering in an era of low-cost, high-bandwidth communications and ultimately the internet as we know it.
Wow, so just how much data can these optical fibers carry?
This video playing back right here is sucking in data at around 20 gigabits per second.
That is a lot of data.
Yeah, this is ultra-high definition raw video, but even in this case, the optical fiber is not anywhere near capacity. The bottlenecks are here and here, not here. The practical limit of data transport over optical fiber keeps increasing. Using today's technology, it's possible to transport more than 1 million gigabits per second, about a petabit. That'd be like downloading 17,000 high-definition movies from Netflix in a single second.
That's amazing. Okay, tell me about this stuff.
Well, obviously it's an optical fiber as well, but instead of sending light through one end and out the other, it emits light throughout its entire length.
Cool. What's it good for?
I have no idea. Okay, so I was able to seriously bend a strand of glass. Didn't break. But what do you think's gonna happen when I try to bend a pane of glass? Rhetorical question. Check this out.
That doesn't look like it went very well.
Well, that was soda lime glass, the kind of normal stuff we see around us every day. But watch what happens next. This is glass too. It's called willow glass, also made by Corning. And it's flexible.
No way! I cannot believe that is glass.
Well, it is. There's no trickery here. This is glass, but it's as flexible as paper.
So what kind of applications does that have?
Well, that's where it gets really cool. Check this out.
All right, it looks like a piece of stainless steel. And what is this? Willow glass bonded to one side as a scratch-resistant coating?
Yep.
Okay, but tell me this, how is the willow glass anywhere near as durable as stainless?
Well, that's a good question. Watch this.
That is amazing! I cannot believe that the blade did not shatter the glass.
It didn't. And that's just half the story.
All right, so what are we doing?
Give me that.
Okay.
Take this.
This is heavy, man. What do you want me to do with it?
I want you to drop that right on that piece of stainless steel with the willow glass on it.
Seriously?
Let's see what happens.
Here we go. 3, 2, 1. No way!
It dented it, but it didn't break the glass.
That is insane.
And you can attach this to just about any solid surface.
Bendy, flexible, durable glass. Impressive. And characteristics you wouldn't normally associate with glass, right?
Right. I like this new glass age we're in.